we have an unbalanced Wheatstone bridge. You can see the resistors attached and the cell, 1.5 volt cell here. Now, the figure is an unbalanced Wheatstone bridge. 1. Calculate the current through the galvanometer, that is the current here. When the position of the galvanometer is interchanged with the cell, calculate the current through the galvanometer. They are telling us that the position should be interchanged, and then we will calculate the current through the galvanometer. Now, as it is, let's go ahead and calculate the current through the galvanometer. Let's look at it like this. The cell here is going to give us current I. And this current, on coming here, it will branch. We have I1 here and I2 here. As it is going on here, let's take it like this, that IG will flow like this. And this I2 will separate and give us a balance of I2 minus IG here. This I1 will move on and it will connect with IG here. So we are going to have I1 plus IG here. And when it comes here, the two of them will meet. Let me see. I2 minus IG plus I1 plus IG is going to give us I1 plus IG, which is I. So everything now makes sense. Now, we have analyzed the flow of the current using Kirchhoff's law. That's the first law. Now, let's look at the loops. Let's look at this. Loop ABDA. So I can now say 199 I2 plus this one goes like this one plus 20 IG minus 20 I1 is equal to 0. So I can easily say 199 I2 plus 20 IG is equal to 20 I1. Let's look at loop BCDB. Loop BCDB. So please always for loop BCDB. I can now say 100 into I2 minus IG minus 10 into I1 plus IG. You can see this one flows in this direction. So minus 20 IG equals 0. So I can now say 100 I2 minus 100 IG minus 10 I1 minus 10 IG minus 20 IG equals 0. So you can now say 100 I2 110 minus 130 IG minus 10 I1 equals 0. So let me divide 2 by 10. I can now say 10 I2 minus 13 IG is equal to I1. So let me name it like this. This is equation 1, equation 2. Now let's look at another loop. ABCFA. Loop ABCEFA. So look at it. It flows straight, flows like this, and then it comes down. So I can now say 1.5 is equal to 199 I2 plus 100 into I2 minus IG. So I can say 1.5 equals 299 I2 minus 100 IG. So from here I can say that I2 is equal to 1.5 plus 100 IG over 299. So it's making the job easier now. Let's call this one our number 3. Next again, let's look at loop ADCEFA. Loop ADCEFA. So that means 20 I1 plus 10 into I1 plus IG equals 1.5. This is 1.5 here. And this one. So I have 30 I1 plus 10 IG equals 1.5. So I1 is equal to 1.5 minus 10 IG over 30. can see, I can either substitute this one, and this one in this place to get my IG, or I can substitute here to get my IG. So I rather substitute it here. Let's see. Now substituting for I1 and I2 in equation 2. I can now say 10 into 1.5 plus 100 IG over 299 minus 13 IG is equal to 1.5 minus 10 IG over 30. So let's multiply through by the LCM 2990. 299 times 30. So I'm going to have 300 into 1.5 plus 100 IG minus 299 times 30 times 13 IG will be equal to 299 into 1.5 minus 10 IG. So on factorizing, I'm bringing like terms together. I got this, and then all of this. So at the end of the day, I got 1.5 equals to 83620 IG. So I work it out here, and this is what I got. So that is the current that flows through the galvanometer in this, where it is fixed in the center like this. Now let's see where it is interchanged. What will be the current through it? Now let's take it loop by loop. We have interchanged the galvanometer and the cell. So let's say the galvanometer current is IG. So it flows like this, IG here, and then comes here, IG. Now, since IG, we have agreed. So let I leave the cell. So we allow I1 to come down and I2 to go up. Like that. So on coming here, IG plus I1 will be. So we have I1 plus IG here. So it will go up. I2 goes up and it will split into IG here, and this place will be I2 minus IG. So it will come down. So this one goes up. This one comes down. This one goes up. Now let's look at the loops. We have done the analysis on first Kirchhoff's law. So now let's look at the voltage side. Let's look at A, B, loop A, B, C, E, F, A. Let's look at what that one will give us. We have 199 plus 199 into I1 plus I2. You know this one flows against it. Minus 100 into I2 minus IG. You understand? But this one flows in this direction. So plus 20 IG is equal to 0. So let's see. So I have 199 I1 plus 199 IG minus 100 I2 plus 100 IG plus 20 IG is equal to 0. So I1, that's all. 199 I1 minus 100 I2. This one is 299 plus 299 319 IG is equal to 0. So I can easily say that I2 is equal to 199 I1 plus, okay, let me 100 I1, I2 is equal to 199 I1 plus 319 IG. Let's call this equation 1. Let's look at loop A, D, C, E, F, A. Loop A, D, C, E, F, A. You can see that it flows down like this. This one goes up. So let me take the first part. So that is 10 I2. 10 I2 plus 20 IG minus 20 I1 is equal to 0. Like this, like this. Okay, so from here, I can now say that I2 plus 2 IG minus 2 I1 That's equation 2. Now let's look at another loop. Loop ABDA. Loop ABDA. So I can now say 199 into I1 plus I2 plus 20 I1 is equal to 1.5. So I can say 219 I1 plus 199 IG is equal to 1.5. 219 I1 plus 199 IG is equal to 1.5. Therefore, I can say that I1 is equal to 1.5 minus 199 IG over 219. Let me make this one equation 3. Let's look at loop A, loop B, C, D, B. Loop B, C, D, B. So I'm going to have 10 I2 plus 100 into I2 minus IG. So I have is equal to 1.5. So I have 110 I2 minus 100 IG is equal to 1.5. So I2 in this instance is going to be 1.5 minus plus 100 IG over 110. So let me call this one 4. Now let me substitute this one and this one in this equation. So I have 2 into 1.5 minus 199 IG over 219 is equal to, what's I2? 1.5 plus 100 IG over 110 plus 2IG plus 2IG. So let me do that. So I gathered the terms, and at the end of the day I was able to get 1.5 to be equal to 113,860 IG. So IG is 1.5 over 113,860. So at the end of the day I was able to get 13.2 microamperes. So that's the simple way to go about it. Just make sure you get the junction analysis and the loop analysis. Once you get that one, every other thing is mathematics. Thank you very much. See you in the next class.